All right, here's the first bad boy we're going to graph. Let's use our steps to graph this dude. I'm going to go ahead and throw up the 4 important things that I got to have in the back of my head while I graph. If you want to use the 7 points, that's cool too. I'm going to use the 4. All right, number 1, we got to find our intercepts. So to find our intercepts, the first thing I'm going to do is I want to plug in 0 for the x. This is going to give us our y-intercept. Once I do that, I get 3 over 0 minus 2, which would give us 3 over negative 2, which on the graph would look like this, 1 and 1/2, and don't forget your negative sign right there. Okay, next we're going to do our x-intercept, and to find our x-intercept, we're going to set the whole function equal to 0, so take out g of x and put in 0, because g of x is your y value, and we want the y value equaling 0. We have 3 over x minus 2, and to get rid of that denominator, we would multiply both sides by x minus 2, but see when that happens, the x minus 2's cancel out right here, and then when I multiply the other side by x minus 2, we get 0. So we get 0 equals 3, which means that we have no x-intercepts. All right, let's check out our asymptotes really fast before we start trying to graph. The first intercepts I'm going to look for, first asymptotes I'm going to look for is the vertical asymptote. And to do the vertical asymptote, I'm going to set the denominator equal to 0. Our denominator is x minus 2 right there. Most of you guys probably don't need to set up the equation. You can see that x equals 2 is going to be your vertical asymptote. Now I'm going to pause for a minute to talk about our domain, because the vertical asymptote is what informs us on what our domain is. Now normally, when you think domain, I want you to think of the x-axis. And the x-axis goes from negative infinity to positive infinity. A lot of functions are all real numbers, so that would be negative infinity to positive infinity. But the vertical asymptote breaks up the x values and says that you cannot have a 2 in there. And so the way you would write that is you would say negative infinity to 2 with open parentheses combined with 2 to positive infinity. So you're breaking up the all real numbers and you're excluding the 2 and only the 2. Unless you have more than one vertical asymptote, you normally only have to do that. Split it up at one spot. All right, next, what we're going to do is we're going to look at the horizontal asymptote. And to look at the horizontal asymptote, you got to look at the degree of the denominator and the degree of the numerator. If the numerator had an x, it would be x to the 0, which we don't write normally because x to the 0 just equals 1. Because anything raised to 0 power equals 1. And 3 times 1 would just still be 3. So, because the degree on the numerator is smaller than the degree on the denominator, then we get our favorite horizontal asymptote, which is simply y equals 0. All right, so we got x equals 2, y equals 0. Let's go ahead and draw our graph to get an idea of what everything looks like. Because before we start doing extra points, we're going to have to see where our vertical asymptote is. So to start us out, we have our y-intercept at -1 and 1/2. So I'm going to draw -1, -2. So that's -2 right there. -1 and 1/2 is right about there. And then we have no x-intercepts. So we go over to our vertical asymptote. And we have to go over to 2 and draw our vertical asymptote. I'm going to use red for this guy. Beep, 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 beep. And then we have our horizontal asymptote at y equals 0. So because it says y equals 0, we look at the y equals 0, which actually is the same as x equals 0, and draw a horizontal line. Next, I'm going to pick some extra points. Now, I don't need to, because you see how I already have a point right here? I know my curve is going to be right here. It's going to look something like this. Don't forget, your curve is attracted to asymptotes. So the farther this goes, the closer to this line the curve needs to get, and same with over here. The lines will always end going closer and closer to the asymptotes, but most of the time, 95% of the time, the curve never actually touches the asymptotes. All right. Now I'm going to show you, however, though, what it would be like to find extra points. You could make a chart. Actually, I probably wouldn't put y. I would put g of x. We don't need to pick 0 because we already picked it, and we got -1 and 1/2. If we wanted to, we could pick this 1 right here to see if we get something that would be approximately right there. we could pick a 1, and what would we get? Let's see, we get 3 over 1 minus 2. So that means we would get 3 over negative 1. So this would be a negative 3, which is about right. I mean, negative 3, that's negative 2. This would be negative 3 right there, maybe. About so. And so we're dead on. Okay, cool. That point's cool. It just confirms what we're doing. But what about this side right here? Now, we could do the negative x test, the test for symmetry. And this x is kind of annoying me. It doesn't need to be there. Or we can just pick a number after the 2 to see if our curve is going to be right here. Whoops. Or if the curve is going to be right here. Most likely, I think for this one, it's going to be up here. But let's go ahead and do it. Let's test a 3. Let's put a 3 in and see what we get. We have 3 over 3 minus 2. That would equal 3 over 1. So it's a positive 3. Is that right? Yeah, that's right. I don't want to go too fast here. So let me get rid of that stuff. It's in the way. So we got a positive 3. So 3 gives me 3. So this would be 3, and we have 1, 2, 3. We put a dot right here. We can see and be confirmed like, oh yes, the other curve goes right there. And actually, we wouldn't have origin of symmetry because this vertical asymptote is not on the 0. So testing for symmetry is kind of pointless here. And the last step is making sure it's curvy. It's not really a step, I guess. So I got my curvy lines. That's it. This dude's done.